Okay, we're back. Hopefully you tried the top hat. I've never done a symbolic answer question on top hat, so hopefully it wasn't too annoying and you figured it out. The derivative of x to the power 7 is f prime of x equals 7x to the power 6. So when you do the derivative, the 7 jumps down, you get a 7 in front, the 7 turns into a 6 in the power. Okay, derivative of a constant, this is an easy one. The derivative of a constant is the next rule. So if k is a constant, a parameter, then the derivative is 0, f prime of x equals 0. This one is really easy to do with limits, so I'm not going to give a bonus for that, but you can try to prove it using limits, or you can do it using a graph. So what does the graph of a constant look like? It's a straight line. So here's the x and y axis, here's the graph of a constant. So what is its slope? It's just 0. Okay, graphically, since the constant function is a horizontal line, it has no rise over any non-zero run. So the slope must be 0. Okay, 2 limit rules down. Okay, example 6. Find the derivative of 672. The derivative is 0. So it's the function that's always 0. Okay, 2 down. Okay, derivatives of logs. Here things start to get a little interesting. Here is the reason, we're finally getting to the reason in this course. What the hell is the point of the stupid ln function? Why do we care about the ln function? Why do we care about e? Why don't we just use log base 10 or log base 2, some numbers we know about, not the stupid e number? Why are we doing it? The reason is the log base e and e itself have very nice derivatives. They are exactly defined so that their derivatives are very nice. What's the derivative of ln of x of this funny log base e? The derivative is this beautiful function, 1 over x. It's 1 over x. Important thing here, log was only defined if x is bigger than 0. So it's 1 over x if x is bigger than 0. That's going to come up later in the course, so keep your eye on that one. That's the derivative of ln, the natural log. What about other logs? For other logs, the way you do the derivative is you use the log replacement rule. So the log base a of x is equal to the ln of x divided by the ln of a. And by using this rule, you can figure out that when you do the derivative, you get this extra factor of ln of a on the bottom. So what's the derivative of log base a of x? It's 1 over x times the ln of a. Okay, that's rule number 3. Let's do the derivative of the log base 4 of x. Should I make this a top hat question? Let's not make it a top hat question. Let's just plow through. F prime of x equals 1 over x times the ln of 4. And this is for x bigger than 0. Of course, if x is less than 0, the function is just not defined because logs are not defined for things being less than 0. So watch out for that. Okay, here's a tricky one. The log of the absolute value of x. Here's a tricky one. I was thinking about this problem the other day, and I think the only way to do it is by drawing a graph or something like that. So I'm not sure what the person who wrote these notes was going for, what we're supposed to do. I'll tell you what the answer is, and then I think you guys can figure it out a number of ways. When we get some of the other rules, when we get the chain rule and stuff like that, then we'll be able to do it in more detail. But for now, I'll tell you what it is. The log of the absolute value of x, it's equal to 1 over x. So just like before, but now it works for all values of x, for any value of x. So it works for x bigger than 0 and for x less than 0. And I think the easiest way you can see that if you ever forget this fact is to do a quick Desmos. Let me get a quick Desmos open.